Hi guys, let's do something very, very interesting here. It's called sigma notation. Sorry Chris, sorry, just to interrupt you, is this segment 3? Is that segment 2? Are we on segment 2 or 3? Okay, segment 2, sorry. Okay, let's have a look here. Sorry, let me go back. I'm jumping the thing there. Okay, all right. Okay, so we're in segment 2 now, hey? Okay, all right, good. Okay, let's do this. Right guys, welcome back. And I'm glad you're staying with us here. We're going to be doing something quite fascinating in this little second part of this lesson. Okay, now I want you to read this. This is to me absolutely brilliant. Using quadratic number pattern theory. Using quadratic number pattern theory to calculate the sum of the first 100 terms of this thing. So we're going to be using this thing. Okay, now this is 3, 5, 7, 9, 11, which is linear, you adding 2. But we're not going to use now the SN formulas for the matric. I want to do this at a grade 11 level. I want to show you something absolutely fascinating. Now look at this. There's 3, 5, 7, 9, and 11. It's linear. It's got a constant difference. And we want to calculate the sum of the first 100 terms, but I don't want to use Sn as n over 2, 2a plus n minus 1d for the matrix. You're in grade 11, and let's suppose they give it. You know what's amazing? This actual quadratic number pattern helps us to almost get to the Sn formula for matric. But now watch this. Let's have a look here. If you take this, there's your number pattern. Okay, what's the sum of the first term? The S1, the sum of the first term means you're just bringing 3 in. So we bring 3 in. We now work out the sum of the first 2 terms, which is clearly 8. No problem. 3 plus 5 is 8. What is the sum of the first 3 terms? 3 plus 5 plus 7 is 15. That's 10 plus 5 is 15. What's the sum of the first 4 terms? Well, that's 10, 19, and 24. So you adding those sums, the sum of the first 3 terms. Look at the sum of the first 5 terms. If you add up 3 plus 8, or 3 plus 5 plus 7 plus 9 plus 11 gives you the sum of the first 5 terms. Now look at this. You've got 3, 8, 15, 24, and 35. This, what is this? These are the sums. The sum of the first term, which is put in there, the sum of the first 2 terms, the sum of the first 3 terms, and so on. But now what is this? Now we've got the sums, these sums. Now we can then work out, so if you look at these terms, the sum of the first 3 terms is 15. But now what can we do that will enable us to get the sum of the first 100 terms? Using the quadratic number pattern theory, not SN. Oh, I'd love to ask that exam question. Now watch this. Okay, now let's have a look. There's your 3, your 8, your 15, your sums. The difference, the first difference is 5. Look at this. 8 minus 3 is 5. 15 minus 8 is 7. Okay, 24 minus 15 is 9. 35 minus 24 is 11. Now look at this. Now look at this. You've got a look at this. You've got a constant second difference, a first difference row. And look at this. If you add 2, add 2, add 2, you're going to land up getting the constant second difference. Now what is that? That is a quadratic number pattern. And you're dealing with the sum of the linear. This has got to be the most amazing thing. How the quadratic pattern links in with the matric work, the sum, the grade 11 linking in with the 12, the sum of n terms, the sum of the 100 terms using the matric formula can be done using a quadratic number pattern. So grade 11s, you can even do this as well. Okay, now have a look here. This is exclusively grade 11 at the moment, but everybody can benefit. Now what do we know? 2a is 2, 3a plus b is 5, and a plus b plus c is exactly 3 there. This is the golden rule for quadratic number patterns. Remember, boy meets girl, 2a, romantic. 2's a company, 3's a crowd. 3a plus b is bad, and a plus b plus c is, of course, this. Okay, 3. Now, what is then a equal to? 1. 3 times 1 plus b, let's plug it in and bring it across. B is 2. And then what is this? 1 plus 2, a is 1, b is 2 plus c, which gives you 3 and then c is equal to naught. Okay, so what can we then do is we can now remember a is 1, b is 2, c is naught. And we've got our little formula. Now look at this, a n squared, which is the 1n squared, the bn is 2n, and the c was naught. Now that is brilliant because it's going to help us to find the sum of the first 100 terms. Remember, this is the general term of the sums. So have a look. So the sum of the first 100 terms is 100 squared. Remember, the n is 100. n is 100, 100 squared plus 2 times 100, and you get that. Really, really quite nice stuff to focus on. Okay, so people, if we look at this, what do we know? We've got the, let's just revise this now quickly. I'm going to talk to you. What do we know? We've got the linear number pattern. What is that? Where you've got a constant difference the first time round. Okay, now what do we do if we're working with terms? Well, a plus n minus 1b, or what do we have? The b plus c. So remember that with linear. Okay, what is the quadratic? It's going to be when you've got you got the row, you get a first difference row which is actually linear, and then you get the constant second difference. And what do we use? 2a, 3a plus b, and a plus b plus c. Okay, and so watch out for those things. And guys, don't go away. We're going to be back with some more wonderful maths on the Trick Ups Are Loaded.